Welcome back to the series on how to begin data analysis. Today, we'll be covering measures of disease frequency. Basically, aspect is under the subject of epidemiology. Epidemiology is the study of determinants, distribution, and frequency of disease. In this, epidemiologists study who gets disease and why. Study both risk and sick as well as well to determine who get disease and those who are spared and why. This particular aspect of measures of disease frequency comes under descriptive epidemiology, measuring of frequency of disease or of a health outcome or a risk factor, and its distribution. Distribution related to age, gender, geographical time distribution in the population. Now, basically, the uh, measures or computations used in the epidemiology are statistical in nature. Now, we talk of types of data we have been talking about, categorical and measurement data. Now, this is a measures of disease frequency uh, uh, eh, for qualitative data, especially for nominal disease present or disease absent. We'll be counting and the number, and with the help of some measures, we present the disease burden. And mm, for measurement of disease of health, disease or health outcome as a whole, the measures broadly used are prevalence, risk, rate, and odds. So many of us are familiar with the prevalence of anemia in the community, prevalence of ARI. So risk and incidence are synonymously used. Rate is used for the new disease only, but it is for a dynamic population. Odds is another measure where these above two measures are not available, and our study as such is not a follow-up study. So a measure of disease occurrence in terms of a mathematical uh, ratio is used as odds. We'll speak about them, each one of them, one by one. Prevalence is the proportion or percent of an existing disease in a given period out of the total individuals studied. So you have, when you say proportion, you have numerator and a denominator. Numerator is the existing cases of the disease, and denominator is the total population in the study, total individuals in the study population. So no follow-up is required in this study, and it depends on the duration of the disease. Then comes to risk. Risk or incidence or cumulative risk, synonymously used, or probability of disease, probability of getting a new disease in a given period, as against the prevalence where all existing old or new cases both are included. As against that, this includes only new cases in a certain period out of the total people at risk. So numerator counts the number of new cases of the disease. Denominator is the population at risk. This requires a follow-up of individuals. Rate. So as against risk, we'll explain in a little later. So rate is for a dynamic population where individuals are not starting at one point, joining at different time points. so that their contribution is counted. This is also basically probability of getting a new disease, but uh, in the numerator it is same number of new cases in the disease, but in the denominator as compared to risk, in the rate, in the denominator we have percent time contributed, and accounts for a dynamic population. We'll see with an example later. So rate is not fixed like risk, and this also requires a follow-up study. Then odds. Odds is the ratio of cases to non-cases. Here, it's not a proportion. Uh, so in this numerator are cases, existing cases in the disease, and denominator is the number of non-cases. So disease present and disease absent in the occurrence or non-occurrence ratio will be, so or a ratio of probability that an event will occur uh, to probability of event non-occurrence of the event also can be put it in the same fashion per odds ratio. Now measures of we'll go for how they are computed with examples. The measures of disease frequency, for the first one we took was prevalence. Prevalence is equal to prevalent cases, all cases at a given period, given time divided by the total number of individuals in the study population. So prevalence, so the numerator is a part of the denominator. So prevalence is a proportion. Now let us look at the example. We have a data on anemia status versus gender in a rural community. So this is the kind of data, a two-way table. We talked about this, how to generate two-way table when we have anemia, yes, no, and factor boys and girls, or factor some factor present or are absent also. So in this case, you have total anemia are 72 and non-anemia are 175. Total boys are 115 and girls are 132. So out of 115, 21 boys are anemic, and out of 132, 51 girls are anemic. So then what is the proportion of anemia in among boys, which is 21 divided by 115, and what is the proportion of uh, 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 anemia in girls, 51 divided by 132. If you multiply it by this by 100, so you will get, so that could be called as prevalence of anemia also. When we don't multiply, it is we call it as a proportion. Then coming to risk, another measure of disease frequency. Risk is the numerator. In this case, numerator is only new cases, newly detected cases. That means you require a follow up of a group of individuals without the disease of interest. Then, as and when a particular individual gets the disease, he or she will be the part of the numerator out of the total. So, out of the total at risk individuals. Risk also refers to incidence or probability of that health outcome. This is also expressed as a proportion. Comes to example related to this. So in this we have, let us suppose we have total 600 women data we have. It's a tabulated pre-cancer versus HPV status. HPV is human papilloma virus. Uh, so, if we look at it, ignore HPV, we look at the total number of women. So, out of 600 women, pre-cancers are 81, and non-pre-cancer, normal are 519. So, uh, you can also, what is the risk of getting seen? We can calculate. So when we follow up about 600 women, uh, we got 81. So 81 new cases divided by 600 will be mm, the risk of getting CAN. So we can see individually also in a group of HPV positive women. So out of 300 HPV positive women, 77 are found with precancer. So that is about 25.7%. So I look at this also. There is another group I have, HPV negative. So out of 300 women, precancer was found in them also. 4 divided by 300, which is 1.3%. So this aspect of comparison of these will take up in the next talk. Uh, Only we are talking about magnitude, descriptive epidemiology here. Now coming to measures, the third measure is rate. So rate is also measures an occurrence of new cases like risk of disease of health outcome in the population, but it accounts for a dynamic population. So where we can assume that for while calculating risk, all women started at one time point, and they are followed up, and we observed the presence of a detection of a precancer. As against that, in any situation, um, mm, so women keep coming and getting screened. So in a months duration, weeks duration or months duration. So as and when they come, so we include their contribution. So here their contribution we talk in terms of percent time contributed. So that percent time risk we use in the denominator here. Not a fixed like the risk. Thus, rate is not a proportion like risk. Now, how do you compute rate? Uh, Rate is the number of new cases, incident cases divided by percent time. In order to understand percent time, consider few individuals joining the cohort at different time points and contributing in the follow-up, either full or partial. Now, in order to understand the percent time, consider five subjects joining in a cohort at different time points and contribute at different durations. So, for example, subject one enrolled in the beginning of the first year and contributed up to the end of year four with an outcome of death. After that, so contributed only four. Then subject two contributed 8 consecutive years. All, if the study targeted is for 8 years, so he or she contributed for all 8 years. Third subject uh, contributed up to six and make case of missing for 1 year. So contribution is and subject four at the end of second year. So first year he did not contribute, he or she, and last year also did not contribute. So 5 years contribution. Subject 5 joined in the beginning of the year, last to follow up in between 1 year. Then that is the reason the contribution is 6 per year. Now, so diagrammatic presentation looks like this. Subject 1 joining here, joining here, joining here, and they're leaving the cohort with different reasons, being that subject 4 is joining late and subject 5 is left early due to loss to follow up, due to death and due to disease, death and disease. Total percent time is 28 years will be used in the denominator for the computation of rate. So how we calculate percent time? We count them and uh, write down for each subject, and we have 28 years. One loss to follow, one case of disease, and one case of death. So if we are measuring the disease frequency, so case of disease is 1, divided by total contribution is 28 years, 28 years of time, years of contribution. So then come to measures of disease frequency. Fourth one, odds. Odds of an event is equal to the probability that an event will occur to non-occur. So if we call it as occur is p, and non-occurrence is 1 minus p, and the odds is computed as p by 1 minus p. So odds is another easy to compute measure of disease frequency and can be used when risk or rate data are not available. We don't have follow-up data. You have only cross-sectional. We'll talk of that, and data at one time point. Then so odds is computed as uh, proportion of present occurrence to proportion of non-occurrence. Now let us take an example here, in a 2 by 2 table. So generally any 2 by 2 table, we have already talked about it. A, B, C, D, when we have nominal data, dichotomy, disease present and disease absent, factor present and factor absent, we tabulate in this manner computations. Like this is coronary heart disease, younger age and older age. So this can be tabulated like this. So we have total number of again here individuals 120. So 56. Sorry, this is 26, and these totals are incorrect. Let me talk about here. And in the among younger age group, we have um, 30, 10 are with CHD and 39 are non-CHD. So the ratio of that is odds 10 divided by 39, and this is 16 divided by 25. These are the computation of odds. So actual the ratio, further ratio is compared when we compare younger versus older, that we'll talk about in the next video, where we talk about analytical epidemiology. Now disease frequency measure, and so when to compute a particular disease frequency depends on what kind of by adopting what kind of study design you collected your data. So the measures of disease frequency and association are according to the study design adopted to collect the data. For those, in brief, so we a cross sectional could be a cross sectional study, could be a cohort study. A prevalence is computed for a cross sectional study or a survey, and risk and rate are computed for a cohort study, for a follow up study, and odds are computed for a cross sectional study or even a case control study also. These terminology will explain in a different video. These are kinds of different study data collection formats, and the format under which you collect the data. So objective. Thank you. See you again. Easy by step.